We're going to go ahead and talk about the law of cosines today. Most of you are familiar with the Pythagorean Theorem. That one leg of your right triangle squared plus your other leg of your right triangle squared equals your hypotenuse squared. And the Pythagorean Theorem only works with right triangles. However, the law of cosines will work if it's not a right triangle. Now, you'll notice, for the most part, this part right here, that's just your Pythagorean Theorem. This part that's back here, that's the correction factor for when it's not a right triangle. Now, using A, B, and C, this is what it ends up being. But whatever angle you have here, the opposite side of that needs to go down over here. So in general, whatever angle you put here, the opposite side goes over here. Now, in a triangle, if this is your angle, that's your opposite side. The other two are considered adjacent because they're next to your angle. So you go the one adjacent side squared plus the other adjacent side squared equals your one adjacent times your other adjacent. Now the order in which you put these in here doesn't make a difference because these two you're adding and you can add in any order. These two you're multiplying and you can multiply in any order. So you have three sides and you have an angle. When you're dealing with the law of sines, you need to know three of those four things. So you need to either know all three sides and look for your angle, or you would need to know two of the sides and know your angle to be able to find that missing side. So in this situation, you're given all three sides. Remember, that's a side situation, which proves one triangle, so you don't have to be concerned about that side angle stuff from the last section. Now, if you're given all three sides, you want to end up finding your largest angle first. If you're not given all your three sides, you don't have to be concerned about that. But if you're given all three sides, look for the largest angle. And you should remember from your geometry that your largest angle is opposite your largest side. So the side I'm going to be looking for, or angle I'm going to be looking for, is B, because that's opposite my largest side, and that's 8. So opposite goes here, my angle goes here. Now A and C are adjacent sides, so I'll put A here, put C here. Then minus 2, put A here, put B here, or C here. Now all I have to do is go ahead and get cosine of B by itself. Now, some people will have a tendency to put these numbers together, but we can't put these numbers together because these numbers here are attached to the cosine. So to get rid of 5 squared, I'm going to subtract 5 squared. To get rid of 40 or 7 squared, I'm going to subtract that. Now, this right here is being multiplied by the cosine of B. So to undo multiplication, I'm going to just go ahead and divide by that. Well, if you wanted, you could simplify the top and you could simplify the bottom. And you get negative 10 over negative 70, which is really just 1/7. To finish getting B by itself, you have to undo your cosine, so you have to do the cosine inverse. That's your calculator ready form. You type it into your calculator and you get your decimal approximation. Based on that then, since you have an angle, we'd have an angle B and we have side B, we could actually go ahead and use the law of sines to help us the rest of the way. So we could take the sine of the angle that we know, that we just figured out, over the sine, or over 8, because that's the sine of B over side B, equals the sine of an angle that we're looking for. In this case, I chose C, so then I have to put it over side C. Then I have to try to get C by itself, so I got to undo the dividing by 7. Then I have to undo my sine. To undo sine, that's my sine inverse. So now I have my calculator ready form. I type it into my calculator and I get a decimal approximation of 60 degrees. Now, something you might want to be concerned or aware of, that this angle right here of angle B, since we're using that over here, we're using a rounded answer in our answers over here, or work over here. Sometimes that can mess up your answers. So if you have to use this answer here, you might want to take it out a few more decimal points. when you're plugging it in over here. Now, we can easily find angle A because we have side or angle B and we have angle C, and all of our angles add up to 180. So we subtract from 180 and we get 38.2 degrees. In this situation here, you're given an angle and two sides, and this angle is between your two sides, so it's a side angle side situation, which is only one triangle. Now, we need to find everything else. Well, we could go ahead and use law of cosines here, because we have an angle, and then we'd be looking for the side opposite that angle. It was angle C, so we need to be looking for side C. These are your adjacent sides, so they're going to just go in here and here, 27, 18. Now we need to get C by itself. Well, to get C by itself, all we have to do is undo the squaring, so that means we do the take the square root. This is our calculator-ready form. All we have to do is just type this in exactly as you see it. You don't have to do any calculations. And you get C to be this. By the way, I should have changed colors on this, and we could have had a red C. Or I could have had it as black, and that's the black C. I can't change it to Mediterranean or anything like that, because that's not a color. But the red sea and black sea are actually physical bodies of water. Oh, side note, got distracted there. Got it on a tangent. Well, not really. There's no tangents in this problem. It's just sines and cosines. Okay, so now we have our side of C, and we have angle C, so that's an opposite pair. So I should be able to use law of sines. So I'm going to go the sine of my angle, C, over the side of C. That's going to be equal to the sine of A, because I'm going to look for angle A next, over side A, which is 27. Now I need to try to get A by itself, so I got to undo the dividing by 27, so multiply both sides by 27. Now I have to undo the sine, so I have to do the sine inverse of both sides. Well, that's my calculator-ready form. I type it in, I get my decimal approximation. Now I have angle A, I have angle C. I can easily get angle B because all my angles add up to 180, so I subtract it and I get angle B.